Hello everybody. I think all of you know a little about Coulomb's law. If you don't know anything about Coulomb's law, don't watch this video anymore. Watch something else. So we are dealing with a very interesting problem on Coulomb's law, which is this. So we have two charges, Q1 and Q2, separated by a distance R. We need to find out how the force between the two charges, or the force which charge Q2 exert on one or charge 1 exert on 2 will get affected if a dielectric constant epsilon r of thickness T is introduced between the two charges as shown. So this is the problem which we need to solve. If you want to give it a try for yourself, you can pause the video and maybe watch it again to know the correct solution. So let's get started. If you want to know how to solve this, so let us first of all state Coulomb's law again. So if we have two charges Q1 and Q2 separated by a distance r, then the force between them will be such that there will be a force exerted by 2 on 1 and there will be a force exerted by 1 on 2. The magnitude of both the forces will be same. The direction will be different. So we write F21 vector is equal to minus F12 vector, and the magnitude of either of the charge or either of the force is going to be Q1 Q2 upon 4 pi epsilon naught r square. So this is the form of Coulomb's law which we use to calculate the force which charge 2 exert on 1 and the force which charge 1 exerts on 2. Now we are finding out how is this force affected if we fill the material between them with a dielectric of dielectric constant epsilon r. So if we have the two charges Q1 and Q2 again, this time the material between them is filled with a dielectric of medium epsilon r, and the separation between them is r. So now the new force or the magnitude of the new force can be calculated as, so F nu is equal to 1 by 4 pi epsilon r epsilon naught Q1 Q2 by r square. So this is the new force which we have. So we can say that the force between the two charges get reduced by this parameter epsilon r when it is introduced in a medium of dielectric constant epsilon r. अब इसी सिचुएशन को अगर अपने ऐसे समझें कि how to obtain this force by changing the distance. So if I say I have a charge Q1 and I have a charge Q2 and they should exert the same force on each other. So I am saying that the effective distance between them is R effective. So over here, if I write this magnitude of force, which we equated with F nu magnitude, then we can definitely say that F nu magnitude is equal to 1 by 4 pi epsilon naught Q1 Q2 by R effective square. So if this magnitude is supposed to be equal to this value, then we can definitely say that R effective is equal to root under epsilon r r. So this is a very interesting result which we have. So let me again repeat what we have done so far. We have first of all stated Coulomb's law. If there are two charges Q1 and Q2 separated by a distance r, then what is the force which 2 going to exert on 1 or 1 going to exert on 2? The two forces are going to be equal and opposite to each other. They are in accordance with Newton's third law of motion. The magnitude is same, the direction is different, and we get this value. Now what we are looking for is, if the entire medium between the two charges is filled with a dielectric of dielectric constant epsilon r, then what is the new value of force that we have? So the new force that we have is this value, and we say that the force which we obtain now is lesser than this value, as this force becomes 1 by epsilon r times the older value. So the force gets reduced. Just for a fact check, the force between two charges in water becomes 1 by 80 times of the force which they exert on each other when they are in air. That is, if the force between two charges in air is 80 Newton and dielectric constant of water is roughly 80, then the force which the two charges will exert on each other in water will be 80 by 80, that is just 1 Newton. So over here, if we continue with this problem, so we are saying if the same force is to act between the two charges in air or in the vacuum, then we are saying that the distance between them is changed to R effective. And if we calculate this value, then we get a value like this. Now for this value to be equal to this value, the effective distance must be root under epsilon R. So over here, from the calculation which we have done so far, we can be sure about one thing, that we can change this problem in this way, that there is a charge Q1, there is a charge Q2. The space which is occupied by a dielectric of dielectric constant epsilon R can be treated in this way, that R minus T is the separation which they have in air, and this is T effective, where T effective is the value which we obtain from this expression, which is equal to root over epsilon R times T. So over here we can say that the new distance between the two charge become R minus T plus root over epsilon RT. So this is the new distance which we have. And now if we apply the force equation, then we can say that the new value of force which the two charges going to exert on each other is 1 by 4 pi epsilon naught Q1 Q2 by R naught square, that is R minus T epsilon RT square. So this is the magnitude of force which charge 1 is going to exert on 2 or 2 is going to exert on 1. Now you can look at this expression, and if the question is asked in this way, मैं बार बार ऐसा अपने वीडियो में बताता रहता हूँ, अगर आपको ऐसा ही सवाल दे दिया जाए, ये तो मैंने अभी आपको समझा दिया, सिखा दिया, अगर ये क्वेश्चन डायरेक्टली एग्जाम में आ जाता है तो आप इसको कैसे सॉल्व करेंगे, कैसे सोचेंगे? मैं पहले ऐसे सोचूंगा कि अगर ये T का डिस्टेंस R के इक्वल हो जाए, the entire space between them is filled with dielectric. So I hope majority of the classroom program this is taught 1 by 4 pi epsilon R epsilon naught Q1 Q2 by R square. So if on making the value T equal to R, so if T is equal to R, R minus R will become 0, and we will be left with epsilon RT square. So we get this same value of force. So over here, if we have 4 options, और अगर किसी एक में ये हमारा value आ जाता है, that is in the medium 1 by 4 pi epsilon or epsilon naught Q1 Q2 by T square, तो हम लोग सीधा उसी को टिक कर देंगे. अगर कोई ऑप्शन नहीं है तो फिजिक्स जानने के अलावा कोई ऑप्शन है नहीं. तो फिजिक्स जानने के लिए ये पूरा हम लोगों ने अप्रोच इस्तेमाल किया, and then we calculated the effective thickness of the dielectric slab in air, which is this value, and then we changed this thickness T to the effective distance or the effective thickness over here to obtain the final answer like this. I hope the problem was insightful and helpful for your growth. Keep watching us. Like, share and subscribe.